Good morning to everyone. In the last class, we learnt about the problems on the basis of Bohr-Neighbor cycle. We know that the Bohr-Neighbor cycle is used to calculate the lattice energy or electron affinity or ionization enthalpy for crystal lattice. The equation for this is delta HF is equal to delta HS, delta HD divided by 2 plus ionization enthalpy, electron affinity plus lattice energy. Okay. In this class, we learnt about the fajan's rule. Fajan's rule. Before going to the Fajan's rule, we have to know about the polarization, next polarizing power, next polarized ability. Before the Fajan's rule, we have to know about the polarization, polarizing power and polarized ability. Okay. In that, first one is polarization. What is polarization? It mainly defined as the displacement of positive and negative ions, or it may be also defined as defined as distortion of electron cloud of the anion by a cation. Okay. It means polarization, it means the displacement of positive and negative ions. Here there will be displacement. Positive means cation, negative means anion. The displacement of cation, the displacement of electrons in the presence of cation and the anion. Okay. Or it also defined as the distortion of electron cloud of anion by cation. It means distortion means changing the places, or displacement, or also called from the electron cloud of anion by cation. It means electron cloud means outermost shell. Here there is some anion is there, nucleus. Okay. In that nucleus, anion. Okay, X minus, the electrons are surrounded or revolves around the nucleus. In that, the outermost shell of the electron should be distorted. It means it can be donated to the cation or it can be accepted by the anion. Okay. It means if it is anion, it is attract or accept the electron from cation. Here the outermost shell, for example, here chlorine is there, 17 is the electronic configuration, 1s2, 2s2, 2p6, 3s5. This is the electronic configuration of chlorine atom. In that chlorine, it accepts a 1 electron. Okay, sorry, 3s2, 3p5. Okay. Here it accepts a electron from the sodium. Okay. Sodium, you have know that 11 is the atomic number. Electronic configuration is 1s2, 2s2, 2p6, 3s1. Then this outermost shell in the presence of sodium atom, that should be goes to the or attracted by the anion chlorine. So then there will be the distortion. Here the electron will be replaced to the p orbital. It means cation to anion. Okay, in this way we call it as a polarization. Here the electron should be displaced from the sodium to chlorine atom. It means cation to anion atom. That should be called it as a displacement of positive and negative ions, or it also defined as a distortion of electron cloud of anion by cation. Okay, here the cation should be distorted. In the anion place chlorine, there will be only 3p5. When it accepts a electron, chlorine, it accepts a electron from the sodium, it gets 3s2 3p6. Here it is completely filled. Here the distorted will be occur. It means changes will be occur. So it is called as a polarization. Okay. Next is polarizing power. Polarizing power, that is, the polarizing power is the cation can distort the electron cloud of the anion. It means the cation distorted the electron cloud of anion. This is called it as a polarizing power. The cation should be disturb the electron cloud of anion. Okay, here this you have to consider this example. Here the cation should donate an electron to the anion. In that the chlorine gets a completely filled electronic configuration. Here the electron changes. Okay, the cation should be distorted. Distorted means changes. Okay, that should be called it as a polarizing power. The cation distorted the electron cloud of anion. Okay, next is polarized ability. Polarized ability. In that the polarized ability is the electron cloud of an anion distorted by a cation. Here you have to observe this. In the polarizing power, cation will be distorted the anion. Here the electron cloud of an anion. The electron cloud of an anion should be distorted by a cation. That is called it as a polarized ability. Okay, it means this anion should accept the electron from the cation. Here the electron cloud, it means the outermost shell of the electron lost one electron. Okay, so that's why the electronic configuration of sodium becomes 1s2 2s2 2p6. Then it lost the one electron, so the electron cloud will be distorted by the anion. Okay, this will call it as a polarizing power, polarization and polarized ability. Polarization means the displacement of positive and negative ions, or it also defined as a distortion of electron cloud of anion by cation. Next, polarizing power means the cation distorted the electron cloud of anion. Okay. The next, polarized ability means the electron cloud of an anion should be distorted by a cation. Okay. In the polarizing power, the cation will be distorted. In the polarized ability, the electron cloud of anion should be distorted the cation. These are all about the polarization, polarizing power and the polarized ability. Next, we move on to the fajan's rule. There are 4 rules are there. One by one we have to know about that. First one is charge on cation. First one is charge on cation. How the charge on cation affects the polarizing power. Okay, in that the cation with high charge attracts the electron cloud of anion strongly. It means higher the charge on cation attracts the electron cloud of anion strongly. It means, it says that higher the charge on the cation, it means, for example, cation, X is the cation or Y is the anion. Here the charge will be increases +1 or +2 +3. When the charge on cation should be higher, that cation attracts the electron cloud of anion very strongly. Hence that we explain that higher the charge on cation, greater its polarizing power. Okay, did you get the point? It means charge on cation. It explains that higher the charge on cation, that attracts the electrons from the anion. It means X, it contains a higher charge. It accepts the electron very strongly by Y. Y is an anion. Okay. In that, the polarizing power, how the polarizing power affect, it means higher the charge on cation, greater is its polarizing power. It means the cation should have a higher charge, greater its polarizing power. For example, lithium, it is a positive charge, it gives a +1. Beryllium, it gives a +2 cationic charges. Boron, it gives a +3. Carbon, it gives a +4. Okay, the plus means cation, it means it donates. Here lithium, it donates a 1 electron, so it carries a +1 charge. Beryllium, it is a +2, it donates a +2 charge. Boron, it donates a 3 electrons, so it carries a +3 charge. Carbon, it donates a 4 electrons, it carries a +4 charge. In these, based on these values, we can recognize that which cation has a more polarizing power. Here I am telling is higher the charge on cation, greater its polarizing power. It means which cation have a more charges, that have a more polarizing power. In this, lithium has a less polarizing power compared to beryllium. Beryllium has a less polarizing power compared to boron. Boron have a less polarizing power compared to carbon. Then we know that carbon has a greater polarizing power because it carries a +4 charge. Okay, this is all about the one of the rule on Fajan's rule. Charge on cation, higher the charge on cation attracts the electron cloud of anion strongly. Okay, next, higher the charge on cation, greater its polarizing power. We will consider these example: lithium, beryllium, boron, carbon. In that, carbon has a more charge, so that's why carbon has a more polarizing power. Here lithium has a less charge, so lithium has a less polarizing power. Including charge on cation, including this also, there is a charge on anion. Okay, in that, an anion with higher negative charge, it means higher negative charge, that repels the electron electron cloud towards the cation. Okay, it means you have to observe this. Higher the negative charge, it means the cation have a higher charges, -1, -2, -3, etc. This will repel, it means this is the anion. The electrons should revolve around the nucleus. This is the outermost shell. This will repel, the outermost shell repel towards the cation. It means X plus ion. Okay, this is the main thing. Higher the negative charge on anion, that repels the electron cloud towards the cation. In that, hence higher the negative charge on anion, it is more strongly polarized. Okay, did you get the point? It means the anion should be have the higher negative charges. That anion should be higher polarized. It means higher polarized ability. Polarized ability, it means when the anion have a higher charges, it has a higher polarized ability. In that, the example is carbon have a -4. Next, nitrogen have a -3, oxygen have a -2, fluorine have a -1. Here the carbon, it accepts a 4 electrons, so that's why it carries a -4. Nitrogen accepts 3 electrons, it carries a -3. Oxygen has a -2 and a fluorine has a -1. Okay, in that, according to increasing order, fluorine has less polarizing than oxygen. Oxygen is less polarizability than nitrogen. Nitrogen has less polarizability than carbon, because in that fluorine has a less charge, so it is less polarizability. Carbon has a higher charge, it is higher polarizability. This is all about the charge on anion. It means higher the negative charge, that repels the electron cloud towards the cation. So that's why which anion has a higher negative charges, it has a higher polarizability. In that, you have to observe here, cation we are taking polarizing power. Okay, in that, the cation should be explain the polarizing power, anion should explain the polarized ability. Okay, here higher the charge on cation, greater is its polarizing power. Next, in the anion, higher the negative charge on anion, it has a higher polarized ability. This is all about the charge on cation and charge on anion. Next, the second rule is size of cation. Okay, in that, before going to that, we have to know about the size of cation. Size of cation, it means it donates. Cation means it donates a electron. Okay, in that, for example, sodium, it gives the sodium as the 11 atomic number, 1s2, 2s2, 2p6, 3s1. Okay, when it donates only one electron, so it carries +1 is equal to 1s2, 2s2, 2p6. Okay, in that, if you are writing a electron cloud sodium, for sodium atom, it has a 1, 2, 3 shells are there, 1s, 2s2p and 3s. Here 1s2, 2s2, 2p6, 3s1. Okay, This will be called it as a atomic radius. And also, and it donates a 1 electron and it lost the 1 shell. Here only 1s, 2s2, 2p6, 2s2, 2p6. Here the radius will be decreases. When the radius will be decreases, its size will be goes on increases. Okay, and then in that, the based on the size of cation, we are knowing about the which one has a polarizing power, has a higher. Okay, in that, smaller the size, it means smaller the size, okay, size of cation, greater its attracting power, greater its attracting power. Okay, it means first one is smaller the size of cation, the size of cation should be small, greater its attracting power, hence smaller the size of cation as its higher polarizing power, as its higher polarizing power. Okay, this will on based on size of cation. It means smaller the size of cation. Size means it donates. When it donates a electron, its radius will be decreases. When radius will be decreases, the size will be goes on increases. Okay, in that I will give you. Okay, in that, smaller the size of cation, greater the attracting power, hence smaller the size of cation. Which cation has a smaller size? They have a higher polarizing power. Okay, here I am giving cations and their size. In that, beryllium has a +2, 0.31, magnesium has a +2, 0.65. Okay, calcium has a +2, 0.99, strontium has a +2, 1.13. Based on this will be size. Based on this, here these ions carries a +2. Okay, based on this, the size will be goes on increases. Okay, so in that, which one have a higher polarizing power? Here I am telling smaller the size of cation as its higher polarizing power. In that, beryllium has a higher polarizing power than magnesium. No, beryllium has a higher polarizing power than magnesium, and magnesium is higher polarizing power than calcium. Calcium is higher polarizing power than strontium. These are all about the size of cation. Did you get it? Cation means you already know about that, it donates an electron. In that, smaller the size of cation, greater its attracting power, and also it has a higher polarizing power to polarize a given anion. Okay, in based on these examples, this will be the sizes. In this, beryllium has a less size, smaller size, so it has a high polarizing power. Strontium has a greater size, so it has a less polarizing power. This is all about the size of cation. Another two rules will be explained you in the next class.